All right, everybody, hello and welcome back. Today we're going to do is we are going to work on graphing radical functions. Now, the first thing we are going to look at is a square root function. Now, in order to do that, we need to think about our parent function. The parent function is simply a radical function, a square root function, specifically without any transformation. So in this case, our parent function is going to be f of x is equal to the square root of x. Now, when we're creating our parent table, it is helpful to pick some nice x values that we are going to plug into this function to evaluate. Now, out of habit, most of us are likely going to choose values such as -1, 0, and 1. Now, the problem is if I plug in -1, I cannot take the square root of a negative and get a real solution out. So therefore, I wouldn't be able to graph this function because my output would be undefined. So what that means is I'm going to have to pick positive numbers. All right, so I'm going to edit this a little bit, and we're going to do 0, 1, and 2. Well, the square root of 0 is 0. The square root of 1, and maybe I'll write this out for us. It's like we are taking this and we are plugging in here. The square root of 0 is 0. The square root of 1 is 1. Now, here comes another issue. We have the square root of 2, which is not that nice of a number. It is 1 point something. It is an irrational number. So maybe 2 would not be a good choice for us. So not only do we want positive values, but we are also going to choose perfect squares such as 4. And we could keep going. We could use 9 as an x value, but we don't really want to use anything greater than 9 because if we were to use 16, which is the next perfect square, for example, 16 as an input would be off of our graph for the most part, so that's not something we really want to use. So in this case, we have the square root of 4, which is going to be 2. So our values are 0 and 0, 1 and 1, 4 and 2. And now we could keep going, but 3 points gives a pretty accurate understanding of what this function is going to look like. So I'm going to plot them over here. We have 0, 0, 1, 1, and then 4, 2. And our function is going to continue in that direction, something of that sense. And again, we can't go further to the left because there are no negative values we could plug in for our input. And that actually helps us answer our next part, our domain. The domain is how far to the left and right your function is going to go. Another way to think about domain is what x values can I plug in? Well, we can plug in from 0 all the way to infinity. Those are all positive numbers, and I'm going to put a parentheses around infinity because we're not going to include it, and I'm going to put a bracket around 0 because 0 is included. The reason we're doing 0 to infinity is technically we can plug in any positive we would like. Like we tried before, we could plug in the square root of 2. Now, 2 wouldn't be a great number because, as I tried to say earlier, the square root of 2 is an irrational value, but technically we could estimate that on our graph and could theoretically plot where that is going to be. So all positive values and the number 0 are going to be included in our domain. Now the range is viewed as how low we are going to go and how high our function is going to go, or what our output values are going to be. Well, the lowest possible value I can plug in is 0, and I got out 0. So therefore, the lowest range value I can include is 0. And if we just look at this graph, it's going to the right, but it is also going up. So we are also going to have all positive values to infinity. All right, now we need to graph our transformation function. In order to do that, I'm going to slide this over for us. What we need to do is think back to our previous information and try to determine what type of transformations we have going on. The easiest way for us to do that is to think about where these values are inside of our function. Well, right here I have a -1 that is directly attached to my x value. So what that means is when I plug in an x value, that -1 immediately impacts it. All right, because something immediately impacts our x value or input, it is going to be a horizontal transformation. And because it is a minus or a plus, we are subtracting or adding, it is going to be a horizontal shift or a translation. And remember, horizontal transformations are opposite of what you might think. It says -1, so we want to think to the left, but really it is going to be to the right one. All right, and then we also have a negative on the outside. It's not a subtraction, it is a negative. And this negative is not attached to our x. So therefore it doesn't affect our input. It is not horizontal. It is going to be a vertical transformation. And a negative is going to be a reflection. So we're reviewing a little bit of what our transformations are going to look like. We'll talk about a few more in our next example, but essentially the idea is anything that is inside the radical or directly attached to your x is horizontal, and then anything on the outside, either in the front or the back, is going to be vertical. We have multiplication, which could lead to a reflection or a stretch, and then addition and subtraction is going to be some type of shifts depending on where it is. And I'm going to slide this one over just so it's a little bit more clear. Now what we need to do is we need to apply those transformations to our parent table, because these are all transformations from our parent function. Well, our horizontal transformation is going to affect our x values. We are moving to the right one, so I'm going to add 1 to each of those x's. Now I'll get 1, 2, and 5. What that means is our domain, our x values, is all shifting to the right. So instead of starting at 0, it is going to start at 1 and go all the way to the right again, which is infinity. Now our vertical transformation is that negative on the outside, which is a vertical reflection, which means all of our output values, our y values as you could think, are going to be multiplied by -1. It's a vertical reflection, so it's going to cause this function to reflect over our x-axis. So that's going to leave our output values as 0 times -1, which is 0. 1 times -1 is -1. 2 times -1 is -2. And those are our values. So if we go back over here, just to help us visualize this a little bit, I can start to plot these points before I address our range. So I'm going to 1, 0. And then I'm going to 2, -1, and then 5, -2. And so our function is going to kind of continue in that direction because we can see what our original parent function is going to look like, so we know the general shape it should follow. And therefore, now we can look at the graph and see that our range values go down. So the lowest we are going to go is -infinity. It's going to continue to move to the right, but also down as we go. And the highest it is going to go is 0. All right, and one way we can think about that is we can take these transformations and we can apply them to our domain and range respectively. So this is vertical, so it is going to affect our output values, our range. If you multiply both of these by a -1, just like the transformation we did in our table, we'd get 0 and -infinity. Well, we need to write our intervals from lowest to highest, so it's -infinity to 0. Our domain, we are adding 1 to everything, so take that domain and add 1. Our 0 changes to 1, and infinity plus 1 is still infinity, which is where this comes from. So these transformations are just like the previous transformations we've done before. It is just a new function. We need to backtrack a little bit to figure out what our parent function is going to be, and that's essentially when we take away our transformations, what is remaining. And in this case, it is just the square root of x. All right. Now, if we start to look at a cube root, this is a little bit different. And so I want to use the same idea as we talked about before. We are first going to start with our parent function here, which is the cube root of x. It's called g of x here. And we're going to pick some nice x values to plug in. Now, just like before, I'm going to include some positives and some negatives. If I were to evaluate these, plug them into my function, I would get the cube root of -1. Well, our experience from that last problem tells us that I can't take the radical of a negative. Well, we actually can if the radical has an odd value here. So in this case, it is 3. What this is saying is what value to the third power in our case would give us -1. Well, the answer is actually -1. -1 times -1 is +1 times -1 is -1. That's -1 to the third power. So we actually can take the cube root of negatives. So I'm going to use these three values and continue from there. I have the cube root of 0, which is just 0. The cube root of 1, which is just 1. And that's saying what value to the third power is 1? Our answer is 1. So now if I plot this, I've got some values here. And that graph looks a little bit misleading because we might think that this is just going to be a straight line through. What helps is if I use the next cube value. And the reason that I'm going to do this is because up here, it was easiest for us to use squares because we're taking the square root, which is why I used 1 and 4. Down here, I'm taking the cube root, so it makes sense to use cubes. The cube root of 8 is saying what number to the third power is 8? The answer is 2. So on our graph, if I go over all the way over to 8, 1, 2, 3, 4, 5, 6, 7, 8, I'm going to go up 2, and there is our next point. So what happens is we actually kind of snake through and around for these values, and this is what a cube root function is going to look like. Now, when we graph, we don't really need a fourth point. Again, as long as you know what the shape of this should look like, we really only need 3 values. So these are the 3 that we are going to work with. If you wanted to use other numbers, you could, other cubes, such as 8, or you could do, what is our next cube? Technically 27. Maybe that's not the greatest choice. So I would probably just use these ones. But if you wanted to use, let's say, -8, 0, and 8, you could do that as well. Again, might not be the easiest because I want to avoid using big numbers. Technically, 8's not that big, but it's definitely bigger than 1. All right, so let's address our domain and range. Now, if I take a look here, we realize that we actually can plug in negatives. I can plug in any negative that I would like, and I can plug in any positive I would like. Looking at this graph, it goes all the way to the left, all the way to the right, and nothing stops it. So my domain is going to be -infinity to infinity. Now, our range is going to work the same way. We are moving to the right in this direction, but we're also going up. So although it might not look like that, it's going to continue to move up to the right and continue to move down to the left without anything really stopping it. So our range is going to be -infinity to infinity as well. And that is the parent function of a cube root. Now we need to look at our transformation. So we've got our function L of x here, and I'm going to slide this over so we can label a little bit. I've got a negative on the inside. Remember, multiplication with a negative is going to lead to a reflection. And because this is directly attached to our x, it directly affects our input, and it is going to be a horizontal reflection. Now, this 2 on the outside is multiplication. So therefore, it is going to be a stretch. And because it's not directly attached to the x value, it doesn't directly impact it. In other words, we can see it's outside of our radical. It is going to be a vertical transformation. All right. Now, what's left is we need to apply these transformations to our table. So a negative for our horizontal values means a horizontal reflection. So I'm going to multiply all of these by -1. All right, -1 times a -1 is +1. 0 and -1 is 0, and then 1 and -1 is -1. So it looks like our values just kind of flip-flopped a little bit, which is kind of what a reflection should do. And now we have our vertical stretch. So the vertical stretch means we are going to multiply our outputs by the value, which is 2. So I'm multiplying each of my g of x values by 2 in order to get my new transformed points, which will be -1 and 2 is -2, 0 and 2 is 0, 1 and 2 is 2, and now I can plot those points. So I've got +1, -2, I've got 0, 0, and then I've got -1, +2. So again, this might look like we're going to have a straight line here, but remember, it should kind of curve similarly to our last value, so it's actually going to look something like this. And that might not be completely accurate because we don't have a whole lot of points here. But as you can see, it looks like our red function that was flipped, right? And we have a horizontal reflection. Not really sure what's up with those balloons, but then it was also stretched vertically twice the amount. Instead of going up 1, we go up 2. Instead of going down 1, we go down 2. All right, so looking at that domain and range again, nothing really stops me from going left and right. So my domain is negative infinity to infinity, and my range, again, nothing stops me from going up and down. So I'm going to go from negative infinity to infinity as well. All right, connecting that back to what we had before, our vertical transformation, we can apply directly to this range. I'm multiplying each of those values by 2. Well, negative infinity times 2 is still negative infinity, and infinity times 2 is still infinity. Now, my horizontal transformation, I'm going to take each of those domain values and multiply by negative 1 because we have a horizontal reflection. Negative infinity times a negative 1 is positive infinity, and then infinity times negative 1 is negative infinity. And again, we just put the lowest value first because that's how our intervals work. So this is really all that goes into graphing radical functions. These are the only two types of functions we are going to graph, is the square root and the cube root. But technically we could keep going. We could do the 4th root or 5th root or 6th root or 7th root or whatever it may be. And our process would be the same. We would still try to at first include the radical of positives and negatives. But remember, if that value right on top of our square root is even, that means we cannot include any negatives. Remember, a square root technically has a little 2 in front there that we don't really write. And all odd numbers, we could include negatives. So 3, 5, 7, 9, whatever it may be. All right, so the good news for us is for the cube root functions, the domain and range is always going to be the same, which is negative infinity to infinity. And it will be a little bit different for our square root functions. But really, we just need to focus on these transformations. If we can connect back to what we've done in previous units, anything directly attached to the x is horizontal. Anything outside of the x, or in these cases, outside of the radical, is going to be vertical. Addition and subtraction are shifts left and right or up and down. Multiplication would be a stretch or a shrink. And then any negative multiplication would be a reflection. Okay? Thank you as always, and if you have any questions or concerns, please feel free to reach out and drop a comment. Thanks. Have a good night.